Okay, here is an ALEKS problem that we should be able to do. And it says a chemistry graduate student studying the rate of this reaction where we have carbonic acid that we know is going to break down from previous semester down to water and CO2. And so it gives us a time and the concentration of the carbonic acid over a course of 40 seconds, and then it's going to ask us a couple questions. And the questions that are going to be asked is, what is the rate law for this reaction? And then calculate the value of the rate constant K. Okay, so we have this table right here, and let's just review a little bit from our lecture. Let's go back to this slide here that if I have a first or second order kinetic type of data, then if I were to plot the natural log of the concentration versus time, then that is going to give me a negative line here, and the slope of that line is equal to opposite the rate constant. Okay, so if I were to take that data and plot the natural log of the concentration versus time, then I am going to see, I should see a straight line that will tell me that it's first order kinetics. Now, if I take that same data and I plot 1 over the concentration versus time, I should have a positive slope, and it should be a straight line, and the slope of that line is the rate. And so again, keep those in mind. I'm going to plot the concentration of A over time, the concentration of 1 over A versus time, and if I see those straight lines, then I'll have my data that I need to answer the question. Okay, so let me go back to my ALEKS here. Okay, so what I do, this is how I tackle it. You don't have to do it this way. You can do it on your calculator, but this is how I do it. So the first thing I do is I recreate this table in Excel. So there's time. This is the concentration of H2CO3. Okay, now remember, the two things that I need to plot versus time are going to be the natural log of this concentration of H2CO3, it's first thing. And the other thing I need to plot is going to be 1 over that concentration of H2CO3. Okay, so I'm just going to make a couple of, let me go there and just widen that a little bit so it's easier for us to see. Okay, so let me go ahead and put in my time. This is 0, 10, 20, 30, 40. Let me put in those concentrations, just recreating that table. It's going to be 0.02, 0.0101, 0.00671, 0.00504, and finally 0.00403. Okay, so now I want to create a formula in Excel that is going to, you always start a formula in Excel with equals, and this is going to equal ln, the natural log, and of what number? I'm just going to click on that cell right there, okay, and that is going to give me that natural log. I'm just going to drag that formula on down, and so now I have the natural log for each time point and those concentrations. Alright, so let me go create this over here. I'm going to create another formula. Let's start off with an equal. It's going to equal 1 divided by the concentration. Okay, if I hit return, it's going to give me those numbers there, and I'm just going to drag that formula down, which means that same formula is in each one of these cells right here. Okay, so now let me do my plots. Okay, so I'm going to go ahead and plot here time. I'm going to do this first order kinetic first to see if I see something that is linear. And so if I click on my Excel, let me move this down so it's in the screen. If I click on Insert, a chart. I'm going to do a scatter plot. Okay, so here's my scatter plot, and I can look right away. To me, it is definitely not linear, so this is not first order kinetics. But if you don't believe me, let's add a trend line there. And there's my trend line, and then let's go ahead and put an equation on there. So I'll display that equation. Okay, so you can see a line does not fit that data at all. So this is not first order kinetics. Okay, so I'm just going to delete that. Let's see with second order kinetics. And so instead of plotting time versus the first order equation, I'm going to do it versus the second order equation. So I'm going to plot those two. I'm going to click on Insert, a scatter plot. Okay, that looks very linear to me. If I add a trend line to that, then let's go ahead and put the line on there. You can see it's very, very linear. Let's display that equation on the chart, which I did do. Okay, so here's my equation right here. So it is linear. It is definitely second order kinetics. And so I can write the rate law, and that slope, which is 4.9568, that is going to be my rate constant. Okay, so now let's go ahead and answer these questions in ALEKS. Okay, what is the rate law? Well, the rate law is going to equal to that constant K times the concentration of H2 CO3 and that's going to then, since it's second order, raised to the second power. So that should be my rate law for this particular reaction. And let's go down and calculate the value of the rate constant. Well, that is our slope. And our slope, it says to 2 sig figs, our slope is going to be 5.0. So it wants 2 sig figs, and so that's going to be 4.9, but that 5 tells me I have to round up, so that's going to equal 5.0. So if I click on 5.0, assuming I did everything right, then I'm going to, I need my units. So the units, since this is second order, and you can get that from the plot, or you can just know that. Remember, this is 1 over H2CO3, the concentration. The concentration's in molarity, and so that is going to be molarity, but it's 1 over, so it's going to be inverse molarity, and it's also going to be seconds inverse. Okay, so you get that from your graph that you're gonna, it's rise over run, so the units are gonna be 1 over molarity or inverse molarity divided by seconds or inverse seconds, and so that's how I get my units. Or you can just remember that the units for a second order kinetic integrated rate problem are going to be units of molarity inverse seconds inverse. So now if I go ahead and click on check, assuming I did everything right, then it should tell us that we're correct, and we're not. It says my units are wrong in 2. I think I capitalized S, so let's see if that's the issue. That's annoying. Okay, so now I have small case S inverse units. Okay, let's go ahead and recheck that. Now we should be good to go. And I am good to go. So yeah, I could do everything according to ALEKS, and you do everything right, you make one little mistake and it penalizes you. But this is how to do these types of problems. I use Excel. You can think of other ways to do it. But Excel is very easy for me to do since I do it all the time. And you should be able to do these problems.